Hey class, so this is example 2 of lesson 2.7, and we are asked to solve and graph the solution set on a real number line. And we're given x cubed plus x squared is less than or equal to 4x plus 4. So just like in our first example, we want to get everything on one side so that we can have here, instead of less than or equal to 4x plus 4, we want this to say less than or equal to 0. So to accomplish that, I'm going to subtract 4x and 4 from both sides and end up with the inequality x cubed plus x squared minus 4x minus 4 is less than or equal to 0. Okay, and remember in step 2 we want to solve the equation f of x is equal to 0. So how would we solve an equation that looked like this? Absolutely, let's try factoring by grouping. So from x cubed plus x squared, I can factor out an x squared, and I'm left with x plus 1. And from negative 4x and negative 4, I can factor out a negative 4, and I'm left with x plus 1. And we're going to set that equal to 0 so we can solve for x. So now we can see that I have a common binomial. So I'm going to write this as x squared minus 4 times x plus 1 equals 0. Well, x squared minus 4 is just a, yep, that's right, it's a difference of squares. So we can rewrite that as x plus 2, x minus 2, x plus 1 equals 0. So our boundary points are going to be negative 2, positive 2, and negative 1. And those are the boundary points we're going to look at. Remember, we call these boundary points. Okay, so what comes next? Well, now we're going to plot these boundary points on our number line, and we're going to determine where we need to shade by using some test points. So let me turn my page. Okay, so let's get ourselves a nice little number line here. Okay, so if this is 0, there's negative 2 and negative 1. Oops, negative 1. And here is 2. Okay, got a nice little number line. I can go ahead and plot my 3 boundary points. This time I can make them filled in circles, because remember, our inequality is less than or equal to. So these are filled in points at our boundary points. Okay, so once I've got those filled in, remember, I need to pick some test values to figure out where I'm going to shade when it comes to all of this. So I need a test point for each region. Let's remind ourselves what each region is that we're looking at here. So one of my regions is from negative 2 and below. Okay, that region there is negative infinity to negative 2. So we need to pick a test point for there. For that one, I'm going to test, let's say, negative 3. Okay, I also have a region between negative 2 and negative 1. Okay, so for there I could say, let's say, test negative 1.5. I also have a region between negative 1 and positive 2. So I love to test 0, that's my favorite test point. And last but not least, I have a region from 2 up to infinity. And why don't we test positive 3 for that? And remember, to test these, we just plug them into our polynomial. So I'm going to plug in negative 3 to my polynomial. That would be negative 3 cubed plus negative 3 squared minus 4 times negative 3 minus 4. And so on for the rest of these. So we want to figure out what we get for each of them. Well, when I test negative 3, I end up with, yep, that's right, negative 10. When I test negative 1.5, I get, you got it, 0.875. When I test 0, I get negative 4. And when I test 3, I get 20. And remember here, what we're looking at is the sign of each of these values. We're not so much worried about the value itself, but its sign. Is it negative or is it positive? Well, what kind of signs are we looking for? To know that, we have to go back to our original inequality. So remember, the inequality we wrote was x cubed plus x squared minus 4x minus 4. And let's actually write this down. X cubed plus x squared minus 4x minus 4 is less than or equal to 0. So this is kind of the key point right here. Less than or equal to 0. What does that mean? That means we're looking for negatives. Okay, so let's go back to our test values. Which test values elicited negative numbers? That's right, it looks like negative 3 got us a negative number because it got us negative 10. It looks like 0 got us a negative number because it got us negative 4. So now we know that's where we're going to shade. We're going to shade the region where negative 3 was, so that's this orange region over here. We're going to shade there. Okay, and we're also going to shade the region where 0 came from. That's this yellow region in here. So that's where our shadings are going to be, and this is pretty messy, so I'm going to go ahead and redraw this whole thing on my next page so that we can do our interval notation. Okay, so let's look at this number line one last time. So I've got my number line, here's 0, 1, 2, there's negative 3, 1, 2, 3, there's 3. Okay, so my boundary points are at negative 2, negative 1, and positive 2, and my shading is in between negative 1 and positive 2. I'm shading, and it's also to the left of negative 2, so over here. And okay, I think you get the idea. So let's write this in interval notation. Well, this piece here, that arrow tells us we're going off to negative infinity. So this piece is negative infinity, and it stops at negative 2. And since that's a solid point, we're going to use brackets. So I've got negative infinity up to negative 2, brackets. Union, okay, how can we write this piece here? Well, it looks like it starts at negative 1, and it ends at positive 2. Those are both solid circles there, so those are both brackets. So that'll be bracket negative 1, positive 2. And that is our answer for example 2.
Made with Doodlecast Pro.